Good afternoon, everybody. So in the last lecture, we have to be seeing the things related to the H parameter notation. Did you getting my voice? Please reply. Please reply. Did you getting my voice?
Yes, sir.
Okay. So in the last lecture, we have to be seeing the things related to the H parameter notation, right? So what do you mean by H parameter? That we have to be explained earlier, right? So H parameter indicate that hybrid parameter, right? So for the configuration of your transistor, we doesn't use any of the parameters such as Laplace transform, J transform, etc. Why? Because whatever the parameter coming with respect to the your transistor, that are the different, means some are the impedance, some are the voltage, some of means voltage ratio, some of the current ratio, means all the things are different. That's why we doesn't use the normal configuration for it. We have to be use the mixing of all of the configuration. That is nothing but a hybrid configuration, right? This we have to be seen. Now we have to be seen the H parameter notation. We have already seen there are two equations with respect to the H parameter. We know that when we are applying the signal to the your transistor, there are two things. One is a dependent variable, other is independent variable. With respect to that particular thing, we have to design the two equation. One is equation is nothing but a V1 which is equal to H11 I1 plus H12 V2, right? Now other equation is nothing but a I2 related, right? So that equation indicate that I2, right? I2 is nothing but a H21 I1 plus H22 V2, right? These are the two things as we have to be designed. Now according to that parameter, we have to be find out the particular value of the H11, H12, H21 and H22, right? So we know that H11 is nothing but a V1 upon I1, right? V1 upon I1 indicate that V indicate that voltage, I indicate that current, that should be related to the input. That's why V upon I indicate that it is a resistance, right? But see, in case of other than resistive material, it should be considered as the impedance, right? So V1 upon I1, it should be related to the input, right? That's why it is the input impedance. You know about the Ohm's law are equal to V upon I. So it indicates that impedance. So it should be related to the input. That's why it is the input impedance, right? So for this is a H parameter. That's why we are taking H common for all of the things, right? So H11, H12, H21 and H22, right? So input impedance indicate that first of the input I is taken as here, it should be considered as a HI. Okay, so H11 is further over considered as a HI. Okay, now H12 indicate that actually it is the voltage ratio, that is a V1 voltage to the V2 voltage, right? So any of the ratio which should be output divided by input, it is a forward, but input divided by output, it is a reverse. That's why it is a reverse voltage ratio. Its notation is HR, R for reverse. Okay. Now see H21 indicate that it is the ratio of the current, means I2 current to the I1 current, right? So I2 indicate that output, I1 indicate that input, right? So output divided by input, so it is a forward and it is a current. So that's why it is called as forward current ratio. Okay. So F of it taking here. So HF is indicate that H21. For the H22, what we have to do? I2 divided by V2. I2 indicate that I divided, we know that V upon I, it is nothing but a resistance. But opposite to that, I upon V. So it is a nothing but a I2 upon V2. Both are term respect to the 2 second. That's why it is output. And see, this is output, but with respect to opposite to that of resistance. That's why it is called as admittance. Okay. So that's why it is a output admittance, right? So O of it taken here, so HO indicate that H22. This will be the thing. Means further on, we doesn't use the H11, H12, H21, H22 For that, we have to be written as a HI, HR, HF, and HO. Okay. This is the revised part. That's why I'm taking somewhat fast. Okay. After all, we know that the particular H parameter model and H parameter diagram, right? For that diagram, we have to be seen here a hybrid model. For this hybrid model, we have applied the input V1. So in that time, we have to be flowing the current, that is I1. So H1 indicate that it is the ratio of V1 upon I1. So it should be coming in a first input with respect to it series, right? H11 V1 which is equal to H1 on I1 because I1 flowing through the H11, okay, plus H12 plus H12 into V2, right? H12 into 2. So it should be coming with respect to the output. That's why here is input. Inputच्या साईडला दाखवलं हे आउटपुटच्या साईडला दाखवलं, right? H12 V2. Okay. Now see other equation I2 equal to H21 I1 plus H22 V2, right? So for that purposes, H21 indicate that this should be coming with respect to secondary but part of input, right? That's why H21 is towards the input, right? Towards the side of input. And other equation H21 I1, right? H21 I1 indicate that part of input, right? Other equation H2 to V2. So it should be coming with series of the V2, right? So this is the equation. According to that equation, we have to form the hybrid equivalent circuit, right? In that equivalent circuit, see first equation is nothing but a V1 which is equal to H11 I1 plus H12 V2, right? So V1 which is equal to H11 is nothing but input impedance, right? Input impedance that should be coming with respect to current one. That's why HI in that I1 current is flowing through it, right? Plus H12 V2. H12 indicate that it is the reverse, right? The reverse voltage, right? V1 upon V2. So that's why it is a HR and multiply by factor V2, right? This current flowing through it. Okay. Same we have to be written as the part of the output circuit, right? So for that output circuit, we know that I2 equal to H21 I1 plus H22 V2, right? For the second thing, H22 V2 we have to be first written, right? V2 is input applied. H22 indicate that it is the ratio of I2 upon V2. So that's why it is taking as this way, right? Opposite to that of resistance. It indicates that H22, right? H22 which is multiplied by V2, okay? Plus H22 V2 means H1 with respect to this H21 I1 plus H22 V2, right? For that purposes, we have to be written as a I1. H21 indicate that it is the forward current, that is I2 divided by I1, right? For that purposes, we have to be written as HF multiplied by factor of I1. Okay, this is hybrid equivalent circuit. This is part as we have seen in last lecture, but that also we have seen, but this indicate that actually how the particular characteristic configured as and the common emitter, common base or common collector, right? So see for that purposes we have to be seen the things such as here. 1 minute. See, H parameter of CACBCC configuration we have to be seen here. 1 minute. We have seen the H parameter of CB, configuration, right? So what it indicates that we know that particular thing. We know that H11 is nothing but a P1 upon I1. We have to be consider it as a HI. Okay. हे लक्षात आलंय का तुमच्या H11 ला HI, H12 ला HR हे कसं म्हणतात, कशामुळं काय? प्लीज रिप्लाय द्या मला.
Yes, sir.
See, I'm again tell you, see H11 indicate that it is the ratio of voltage V1 divided by current I1 when V2 is equal to 0. So it is nothing but it should be as like as impedance, right? V upon I, right? So that's why I of it taken as here. So HI indicate that H11, okay? H12 indicate that V1 upon V2, right? It is the voltage ratio, but see output divided by input, it is a forward. So input divided by output, it is a reverse. That's why we have written here as a HR. HR indicate that reverse voltage ratio, right? H2 indicate that I2 divided by 1. So it is a forward, means it is a current ratio, it is output divided by input. So we have to be written as a HF. Okay. For H22, we have to be written as I2 divided by V2. Okay. So in that case, I1 which is equal to 0. Okay. So see, it is a I2 divided by V2, it is nothing but opposite to that of Q1 upon I, P upon I, right? P upon I indicate that resistance, but I upon V indicate that admittance, right? So this will be Q1 upon I related to the input, but I2 divided by V2 is related to the output. That's why it should be taken as a opposite to resistance. It is called as admittance and output thing. That's why it is called as output admittance. That's why we are telling it as a HO. Okay. See, for that thing we have to be seen with respect to common emitter, common base, and common collector configuration. Means which thing which we have to be telling for HI, HR, HF, HO in case of your configuration, that is either your HC, CB or CC. Okay. See, for CE configuration, it in that configuration HI is common. CE, E of it's taken here, so it is nothing but a HI, right? So for the CB configuration, H11 is nothing but a HI common, and B is taken here, so HIB. Okay. For common collector configuration, H11 is nothing but a V1 upon I1, which is nothing but a HI. So for that HI taken as a common, and this C common collector, C is taken as here. So HIC indicate that common collector configuration H11, right? At the same way, we have to be calculate the other thing. Now H12 indicate that V1 upon V2, which is nothing but a reverse voltage ratio. It is a HR, right? For that HR, we have to be taken out this E, HRE, B, HRB, C, HRC. Okay. See, for the H21, it should be written as a forward current ratio. So HF, right? For that HF, we have telling with respect to emitter, base, and collector. For emitter, it is written as HFP. For base, it is written as HFB. And for collector, it is a common collector. It should be written as a C. So HFC. Okay. Accordingly, we have to be seen the things, right? H22, it is nothing but output admittance. So HOE, see, HOE, HOB, here HOB, चुकलंय, HOEF नाही, HOB, कारण common base configuration, HOB, right? HOC, right? These are the thing, notation which should be used hereafter when H11 is coming with respect to common base configuration, we should it written as a HI, we have to be written as a HIB. So HIB indicate that it is nothing but a H11 of the common base configuration or HI of the common base network. Okay. Now we have seen this thing. Actually आपला सिलेबसचा पार्ट इथून सुरू झाला, जे लास्ट टाइमला आपण इथपर्यंत आलो होतो. ओके. सी hybrid equivalent circuit of common emitter, common base, and common collector configuration, right? So for that, calculation is very simple. Why and how I am telling you. See, only thing is changed here. We know that input, which is the input, which is the output, which is the input current, which is the output current. Only that thing we have to be required for this diagram. All other things is whatever the equation with respect to H parameter, that are the same, right? So see, we have applied the input voltage as a VB. In that case, when we have applied the VB voltage, in that case current flowing through the base terminal, right? current flowing through the base terminal, that is called as IB current, right? And at the same time means VB and IB, it is the input voltage and current respectively, right? When we are applying this thing, we have got the output voltage as a VC, and at the same time current flowing, that is a collector current, right? This will be happen. So we know that input current is IB, output current is IC, input voltage is VB, output voltage is VC. Okay, see, so that's we have equation, right? H11 is nothing but a V1 upon I1. We doesn't written here as a V1 upon I1. See here, V1 here, this is this means input applied to it, it indicate that first voltage, that is V1 voltage. So here whatever the voltage applied across it is a V1 voltage. So V1 which is equal to, please tell me, V1 which is equal to VB. Okay, and I1 means current flowing through the input, that is IB. See here, V1 as a VB, I1 as a IB. Okay, at the same time there should be output current. See, this is the output current that are called as I2. So I2 indicate that IC, and V2 indicate that VC. V2 indicate that VC. Okay, this will be the thing with respect to this, right? So during this what we have to be calculated. See, input voltage indicate that VB, input current indicate that IB, and in output current indicate that IC, and output voltage indicate that VC according to the diagram. Means wherever these things required, in that case we doesn't write. See, we doesn't write V1 upon I1, V2 upon I2, we doesn't write it. In that case, if we have to be written as a V1 upon I1, in that case we have to be written directly VB upon IB. Did you understand the concept? मग काय म्हणायचं लक्षात येत आहे का तुम्हाला? याच्या पुढे म्हणजे just see, when we have to be seen the thing with respect to common emitter configuration, in that case your input current. So see, in case of your H11, what it indicate that it is nothing but a V1 upon I1, right? You doesn't write V1 as I1, you have to be directly written as a VB upon IB for the case of your common emitter configuration. Okay, लक्षात आलंय का तुम्हाला काय म्हणायचं ते? Okay, see here, we know that there are two equations of the H parameter. Why we have to be in need of the two equation with respect to H parameter? That's I'm telling you. See, when we have to be calculate the H parameter, right? H parameter, in that case two variables that should be coming with respect to the transistor two-port network, which are that, see, first parameter indicate that dependent, other is independent. For the dependent parameter, there are two dependent parameters, which are V1 and the I2. That's why whatever the equation coming with respect to us, that should be 2, right? So see, V1 which is equal to H11 I1 plus H12 V2, right? This equation is becomes, see, this equation is becomes, we have to be put out the value, right, of the particular case, that is V1 value, I1 value, V2 value, right? So V1 is nothing but a, see here, V1 is nothing but a VB. So instead of V1, we have to be written as a VB. H11, we know that H11 indicate that for common emitter. See, this is the common emitter configuration. For that configuration, HI, right? HI, we have to be directly written here as a HI, and I1 current. I1 current indicate that base current, right? Base current. So your equation is HI into IB plus H12 V2. H12 indicate that it is a, see, H12 indicate that it is a HR, right? This is for common emitter, that's why it is written as a HRE. Okay, so HRE into applied voltage, that is V2 voltage. V2 voltage indicate that VC, we have to be written as a VC, right? See, we know that only thing changed here is that whatever the equation coming with respect to generalized stuff, right? Generalized indicate that when we have to be start up the H parameter network, in that case we draw the diagram of it, taking one parameter as a dependent, other as a independent. With respect to it, we have taking the two equation. In that equation, we have written with respect to V1 and the I2, that are the dependent variable, right? So for that equation, only changes here, we have take out the particular value in case of that particular configuration, either your common emitter, common base, or common collector. So see, we have seen the common emitter configuration. In that configuration, V1 is nothing but a VB, I1 is nothing but IB, and phi2 is nothing but a Vc. So that's why this value we have to be put out this equation earlier, v1 which is equal to h11 I1 plus h12 v2, and the equation forms is Vb which is equal to HIE IB plus HRE Vc, right? This is nothing but equation number 1, right? Equation number 1. So accordingly we have to be seen the second equation, right? For the I2, right? I2 is nothing but a h21 I1 plus h22 v2, right? For that equation again we have to do the same thing, means particular value we have to be put out in this equation. I2 is nothing but a, see, tell me which is the I2 here. IB is I1, tell me which is the I2. Another thing I'm telling you, output current. IB indicate that input current. Now tell me.
I see.
Right. So IC is nothing but output current, right? H21 as it is, right? H21 as it is. For that H21 indicate that it is the ratio of I2 upon I1, right? I2 upon I1. So it should be called as forward current, right? HF, right? HF, and this is for the emitter configuration. That's why it is written as a HEP. Okay. And I1 indicate that, see, I1 indicate that IB. We have to be written here as a IB only. Okay. Plus H22 indicate that it is the admittance, right? So I2 divided by V2, right? I2 divided by V2, right? So it should be called as HO, right? Output admittance, right? HO. This HO for the emitter configuration, that's why HOE, right? HOE into V2 indicate that Vc, we have to be written as a Vc only here, right? लक्षात आलं कसा घेणार? Equation number 1 and 2, we doesn't do any other thing. We have just put out the original equation value of the particular thing only. हे लक्षात येत आहे का? याच्याबद्दल तुम्हाला काय प्रॉब्लेम आहे का? प्लीज असेल तर सांगा, आणखीन एकदा रिपीट करेन मी, कारण हे जर नाही कळलं तर पुढचं काय कळणार नाही. सांगा, लक्षात आलंय की सांगू एकदा? प्लीज रिप्लाय द्या. Okay. See, we know that there are two basic equations with respect to the each parameter network. First equation is nothing but means they see there are only one equation should be coming with respect to the H parameter, but which are that dependent variable and independent variable. That is generalized equation. But see, there are two dependent variable, two independent variable, right? That's why whatever the equation coming, that should be related to the dependent variable, right? So we know that V1 and I2 that are the dependent variable. So there should be two equation forms with respect to it, right? With respect to V1 one equation, with respect to I2 there is a one equation, right? So V1 which is equal to H11 I1 plus H12 V2, right? This is the equation of first equation of the H parameter network, right? So in that equation we have to be written the particular value only in case of particular configuration, right? In case of common emitter configuration, see, V1 indicate that input voltage. So here input voltage is VB, right? So instead of V1 we have to be written as a VB, right? So H11 for the common emitter network, it is a HI, right? So that's why we have to be written here as a HI. Okay. I1 indicate that I1 current which should be flowing in the input, right? So see, that is a IB. Okay. HI into IB plus H1 to V2. H1 to V2, what it indicate that? H1 to indicate that it is the reverse voltage ratio V1 upon V2, right? So that's why we have to be written as a HR, and this is for the emitter configuration. That's why it is a HRE. V2 indicate that C, secondary voltage. It is a secondary voltage. So it is the output voltage. So collector to emitter voltage, that is a VC. So instead of we have to be written as a VC here. Okay. See, this will be the thing. Now I2 indicate that. I2 indicate that other equation I2 equal to H21 I1 plus H22 V2, right? So I2 indicate that, see, this is the I2, right? Secondary current, right? So it is IC. We have to be written as a IC. H21 is indicate that it is the forward current ratio. So it is the ratio of I2 divided by 1. So for that purposes, we have to be written as a HF for the emitter configuration. That's why HFE. And for I1 indicate that first I1 current flowing, that is IB. So we have to be multiplied by IB. Okay, HFE into IB plus for the H22. H22 indicate that it is the ratio of I upon V, right? It is nothing but admittance, right? So we have to be written as a HO, and this is the common emitter. That's why HOE. Okay, Phi2 current indicate that secondary current, that is a sorry, Phi2 indicate that secondary voltage. So that voltage is nothing but a VC. We have to be put out here as a VC. Okay, VC. Okay, this is the two equation. आता लक्षात आलं सगळ्यांच्या? प्लीज रिप्लाय द्या. लक्षात आलंय ना? पूजा कोकटे लक्षात आलंय का? नम्रता गोडके. See, according to that, according to particular equation, we have to be find out the particular H parameter value, right? So particular finding. See, when we have to be calculate the see, for the H parameter network, we have to be find out the particular value, right? So to find out the particular value, I need to get that H11, H12, H21, H22. We have already find out, right? But in this case, we have to be find out the same parameter for it. Means H11 is nothing but a now HI. Okay, H12 is nothing but a now HRE, and H21 is nothing but a HAP, and H22 indicate that it is a HOE, right? These are the four things, right? These are the four things. Means instead of calculation of the particular thing, means H11, H12, H21, H22, we have to be find out the four thing, that is a HIE, HRE, HAP and HOE, right? So see, when we have to be find out the HE, see here we have to be seen here, and then go on next slide. There we have to be find out the particular value, right? So to find out the HRE, what we have to do? We have to be making this thing as a zero, right? So that VC, in this case, C, to find out the HA, we have to be making VC which is equal to 0, right? VC 0 indicates that all the equations should be 0, right? So here HI into IB, right? So HI equal to phi B divided by IB, right? HI equal to phi B divided by IB. See, phi B divided by IB. Okay. See, HI equal to B divided by B, when we have to be taken as a VC equal to 0. लक्षात यामधलं तुम्हाला लक्षात येत आहे का? काही सुद्धा आपण केलेलं नाही, फक्त ज्या टर्म आहेत Phi1 which is equal to इक्वेशन होतं ना, त्याऐवजी Phi B equal to केलंय, एवढाच चेंज आहे याच्यामध्ये. आणि आता फाइंड, सी वी हॅव टू बी फाइंड आउट द पर्टिक्युलर थिंग्स. मीन्स HI indicate that we have taking HI here, this parameter making 0, so that's why here should be making as a 0, so it is a 0. We have this thing, all terms should be 0, so HI equal to this term multiply going on another side as a divided, so HI equal to VB divided by IB. हे लक्षात आलंय का? हे लक्षात आलंय का सांगा?
Yes, sir.
Okay.
Sir.
Here we have to be find out the HI. Now during this equation we also find out the HRE, right? So to find out the HRE, we have to be making IB current which is equal to 0, right? So here IB making 0, so this all the things should be 0, right? This all the things should be 0. So VB equal to HRE into VCC, right? This will be equation coming, right? So HRE equal to VB divided by VC. Okay, HRE equal to VB divided by VC when IB equal to 0. See, HRE equal to VB divided by VC when IB equal to 0, right? So both are voltage, right? No unit, so it is a unitless, right? Now HAP. Here two things, IC equal to HAP into IB plus HO into VC. Now we have to find out the HAP. HAP. To find out the HAP, we have to be making the HOE equal to 0, right? This makes 0 indicate that all the terms should be 0, right? All the terms should be 0. Now your equation is IC equal to HAP into IB only. So to find out the HAP equal to IC divided by IB. Okay, IC divided by IB, right? When we have to be making VC equal to 0. So HAP equal to IC divided by IB when VC equal to 0. See, HAP equal to IC divided by IB when VC equal to 0. Okay, to find out the HOE, right? To find out the HOE, we have to be making the HAP, IB which is equal to 0. So IB 0 indicate that all the terms should be 0, right? So IC equal to HOE into VC. Okay, HOE into VC. So HOE equal to IC divided by VC, right? When we have to be making IB as a 0. I'm again tell you, during this equation, IC equal to HAP into IB plus HOE into VC. In that equation, we have to find out the value of the HOE. So that purposes, what we have to do, we have taking this thing IB as a 0, right? IB 0 indicate that whole thing should be 0, right? 0. So HOE into VCC, which is equal to IC. Okay, so HOE equal to IC divided by VC. IC divided by VC. Okay, IB equal to 0. This will be the thing. And as the same way, we have to be find out the or draw this diagram, such as your H parameter model we have seen here. याप्रमाणे आपण ती डायग्राम ड्रॉ करणार आहोत. याप्रमाणे इनपुट और आउटपुट, right? So see, in that equation, VB as the input voltage, in that current flowing, that is I1, current flowing, that is IB, and in that case there should be a V1 upon I1 indicate that it is a resistance, so that's why it is a HI, and for common emitter that's why it is a HI. Okay, and same time it should be connected with the two equation. It should be coming with respect to the input. One is nothing but a HI, see here, HI into IB plus HRE into VC. So plus HRE into VC, HRE indicate that it is a reverse voltage, right? So that's why V1 upon V2, right? So it doesn't have sign because same thing, right? So it have no sign indicate that it is unitlet. So it should be a multiplying factor of earlier things, right? So it should be a multiplying factor for this, right? HI. Okay, so HRE into VC. VC indicates that it is a voltage source. That's why plus minus sign for it. Okay, this is the thing with respect to input. For the output, see, for the output, it is nothing but IC equal to HAP into IB plus HO into VCC, right? For that case, IC equal to, we have first written as a HO into VC, right? See, VC is the voltage which should be applied to the HOE, right? Because HOE is admittance, that's why it is written in this way, right? VC is applied to the HOE. See, at the same time, there should be, see, I'm taking first, second thing as first, right? So VC is applied through the HOE. At that time, output current flowing, that is a collector current. So that for that thing, we have seen that another equation as a HAP into IB. HAP indicate that it is the ratio of I2 divided by I1, right? So it is the same thing, that's why it doesn't have any unit. So it also the multiplying factor for earlier thing. See, that's why it should be multiplying factor to the earlier thing, right? HAP into IB. So it indicate that IB indicate that it is a current source. That's why its sign is current source only. It doesn't have any sign. Okay, लक्षात आलंय का? हे लक्षात आलंय का? म्हणजे कसं ज्या व्हॅल्यू आहेत त्या त्याच्यात टाकायच्या, नथिंग एनी अदर दॅन द व्हॅल्यू पुट, राईट? याच्यापेक्षा वेगळं काही सुद्धा नाही. याच्यात इक्वेशन जे आहेत V1 which is equal to H11 I1 plus H12 V2, राईट? या इक्वेशन मध्ये फक्त V1 ची व्हॅल्यू टाकायची, H11 ची सुद्धा व्हॅल्यू म्हणायची, कारण का कॉमन मीटर साठी काय येईल, HIE, लक्षात घ्या, राईट? HI इंटू म्हणजेच H11 I1 काय असेल इथं IB असेल, राईट? ते फक्त इथं पुट केलंय आपण, लक्षात घ्या. बाकी म्हणजे ज्या व्हॅल्यू इथं जी डायग्राम दिसते याच्यामध्ये जी व्हॅल्यू आहेत ना, त्या फक्त आपण याच्यामध्ये पुट केलेल्या आहेत. लक्षात आलंय का? सांगा मला.
सर आलंय.
हे जर लक्षात आलं ती लगेच समजते पास सांगतो तुम्हाला. सी वी हॅव सीन द थिंग्स विथ रिस्पेक्ट टू common base configuration, right? Common base configuration, what it indicate that C, common base indicate that its terminal means there are three terminal of the transistor, emitter, base, collector, right? In this case, your base terminal should be coming with respect to input as well as output. That's why it is called as common base, means base is in common with respect to input and output, right? So that's why see, here is the transistor, right? Emitter, base, collector, right? So this during this diagram, base terminal is common, input as well as output. Okay, input as well as output. See here, input as well as output. So what we have to do during this configuration, uh, same thing, means whatever the voltage applied in between your emitter and the base, right? Emitter and the base. So we are applying the voltage in between emitter and base. That's why we have to be written as phi in between emitter and base, right? So आता लक्षात घ्या फी ईबी यायला पाहिजे इथे. लक्षात घ्या आपण एबीसीडी करताना कसं ए नंतर बी घेतो. सेम वे we have to be written first B here, right? That's why initially whatever the voltage applied in between E to the B, that's why it should be written as a VB as the input voltage. At that time there should be formation of the current that should be flowing through the emitter, right? That current is nothing but the emitter current should be called as I. Okay, at the same times this is the base terminal, whatever the current flowing through the output, that is during the collector, that's why it is called as collector current. And whatever the voltage that should be with respect to your output, that in between collector and the base terminal, right? So that's why it should not be written as a VCB, right? VBC, because ABCD chakraman apan gheto, right? So it is a VBC. Okay, so during this diagram as a hybrid equivalent circuit of common base configuration, we have seen that VB is the input voltage applied across your common base configuration. In that case, whatever the current flowing through the input, that is a I, means input voltage is VB, input current is emitter current. At the same time, due to the application of input voltage VB and input current I, there should be coming output voltage, that is a collector. Sorry, there should be voltage coming, that is a VBC, that is the base collector to the base voltage, and the current that should be flowing is called as collector current IC. Okay, this will be coming, right? So in this case, as a V1 voltage is called as VB and current, that is I1, is called as IE, and output voltage is called as VBC and output current is IC. Okay, these four things did you know? या चार थिंग लक्षात आल्या का सांगा मला. या चार थिंगच्या बद्दल म्हणजे V1 इक्वल टू VB, I1 इक्वल टू IE, याच्याबद्दल कोणाला काही प्रॉब्लेम आहे का? त्याच्या आधी हे सांगेन की कॉन्फिगरेशन करत असताना कसे करायचे हे सांगतो. लक्षात घ्या, डायग्राम आहे. आता इथं काय सांगितलंय, कॉमन इमिटर कॉन्फिगरेशन. आपल्याला काय करायचं आहे, तीन टर्मिनल आहेत, कलेक्टर, बेस, इमिटर. इमिटर कॉमन करायचं आहे, त्यामुळे काय करायचं, दोन्ही मध्ये इनपुट आणि आउटपुट मध्ये इमिटर यायला पाहिजे. लक्षात घ्या, तशा त्याप्रमाणे तो अरेंज करायचा, ठेवायचा. लक्षात घ्या, इथं त्याप्रमाणे आपण अरेंज केला. इन केस ऑफ कॉमन बेस, त्याच्यामध्ये बेस कॉमन पाहिजे, त्यामुळे तो तसा न ठेवता बेस खाली दोन्ही साईडला घेतला, त्यामुळे बेस कॉमन झाला. लक्षात येत आहे का हे इक्वेशन कसे आले? V1 इक्वल म्हणजे पर्टिक्युलर V1 म्हणजे VB आहे, I1 म्हणजे आहे, हे कसं आलं लक्षात येत आहे का? काय बोला, लक्षात आलंय का?
Yes, sir.
Yes, sir.
Okay. See, we know that V1 which is equal to VB, I1 equal to IE, V2 equal to VBC and I2 equal to IC. इथं काढले आपण, त्याची इकडे नोट केलंय. Okay, we know that the equation V1 which is equal to H11 I1 plus H12 V2. Now H11, we know that H11 indicate that HI. Initially it is a HI, but it should be for the common base configuration, so it is written as HIB. Okay, HIB. So I1 current is nothing but I. So HIB into I indicate that H11 into I1. हे लक्षात येत आहे का? सांगा, हे लक्षात आलं का? हे जर लक्षात आलं तर पुढचं लगेच येईल लक्षात. हे कसं याच्यामध्ये कन्वर्जन केलंय, प्लीज रिप्लाय. See, I'm again tell you, V1 which is equal to H11 I1 plus H12 V2. It is the equation with respect to your dependent variable, right? So to find out this equation, we have to be particular case, right? Common base configuration. In case of your common base configuration, we know that V1 which is equal to VB, I1 equal to IE, V2 equal to VBC, and I2 equal to IC, right? This we know that. So for that purposes, we have to be written as a V1 is nothing but a VB, right? VB, H11 is nothing but a, it is a HI for B, HIB, I1 indicate that I, so HIB into I plus H12 V2, H12 indicate that H12 indicate that it is the reverse, right? Reverse voltage, right? So HR for that, V2 indicate that VBC, right? HR for base configuration, that's why HRB into VBC, okay? For this is for V1. For the I2 is nothing but H21 I1 plus H22 V2, right? So see, I2 indicate that IC, H21 indicate that forward current, right? So it is nothing but I2 divided by 1. So that's why we have to be written as a HF for the base configuration. That's why it is a HFB. Okay. I1 indicate that IE plus HOB. HOB indicate that common base configuration output admittance, right? HOB into V2. V2 indicate that VBC. Okay, VBC. This is the formation of equation number 2. Now we know that हे value कशा calculate करायच्या. See, when we have to be find out the HIB, in that case other parameter should be 0, right? So HIB equal to VB divided by C, VB divided by, right? To find out the HRB, this making 0, right? I equal to 0, so it 0, so HRB equal to VB divided by VBC, VB divided by VBC. Now to find out the HFB, right? HFB, so we have to be making VBC equal to 0, so it is nothing but IC divided by E, right? Right? IC divided by I, okay? HOB. To find out the HOB, we have making I equal to 0, right? So I equal to 0 indicate that whole thing should be 0. So HOB equal to IC divided by VBC. IC divided by VBC. Okay. This thing we have to be plotted here. Accordingly, this will be forms. Next ला आपण आणखीन एकदा रिवाइज घेऊया. अटेंडन्स द्या फर्स्ट. रोल नंबर 1. रोल नंबर 1. 2, 3 attendance.
Present, sir.
2 का 3?
3.
4, 5,
Present.
6, 7,
Present, sir.
7,
Present, sir. Present, sir.
8,
Present.
9,
Present, sir.
10,
Present, sir.
11, 12,
Present, sir.
13,
Present, sir.
14,
Present, sir.
15,
Present, sir.
16,
Present, sir.
17, 18,
Yes, sir.
19, 20, 21, 22, 23, 24, 25, 26, 26. Provision absent, right?
1 present, sir.
21 present. Roll number 1. 22, 23, 24, 25, 26, 27, 28, 29. Present आहेत की नाहीत? Roll number 29.